Hello all, my name is Krishnayak and welcome to my YouTube channel. So guys, from many days everybody is talking about model retraining approaches. You were requesting me to upload videos on that, how we can understand that, and there is a concept which is called as model drifting, which I have actually told you. So I am basically going to start a playlist on model retraining approaches also, guys. There is just not one approach, there are many approaches. One of the approach which I think that it is better that you all know it, that I'll be teaching you in this. And apart from that, any approaches, and most of the approaches are also been done in directly into the servers right over there. They have different kind of techniques in Azure or in AWS. So I'll be covering that part also in the upcoming videos, but in these videos I'm going to introduce to you a very special library which is called as Creme. Okay, so this particular library Creme, it's pretty amazing with respect to incremental model training. So you can see that Creme is a Python library for online machine learning. All tools in the library can be updated with a single observation at a time and therefore be used to learn for streaming data. Now what does this basically mean? Now guys, always understand that suppose, and what you have learned till now is that you will basically be creating some kind of models. You will be creating some kind of models itself. And when you are creating the model, you are basically using sklearn. You'll be having some amount of data set, and then you will be training it offline, right? And then the mod, you'll be doing all the life cycle of the data science project into it, and finally you'll be getting some better accuracy. And then when you are ready with that, you'll be doing the deployment. But usually in scenarios, in various scenarios in various data science project, you will be continuously receiving live data. Okay, every second some amount of data will be definitely coming, and when those kind of data are coming, you also want your model to get trained continuously with respect to the new data. And guys, if I talk about bigger companies like Netflix, like Amazon, they just don't create one model. There will be 100 different models. Okay, and whenever I talk about model retraining approach, this is one approach wherein whenever we get a new live data, we continuously take it and continuously train it. And yes, with respect to that, again, since there are many models as such, each and every training data will be pushed into multiple models, and then how that specific training will actually happen. Now let me take some approaches over here, and again there are various approaches. Again, I'm saying you guys, this is only the not the single approach. Let me take an example. Suppose from the live stream data, what we do is that from the cloud, right, we take the live stream data, and from this live stream data, what we do, we store that efficiently in the big data, right? And again, for storing it over here, we may be using Spark, we may be using different kind of techniques over here, again for pre-processing and all. Once that data is stored in some kind of databases efficiently, then what we do is that we take those chunk of data, and then what we do incremental training, incremental model training. I'll show you that how does this incremental model training happens in the code itself, and this is what is the whole code that I've actually written, where I'll be explaining about it. I've taken 2 projects with respect to NLP, and yes, in the future I'll also be taking some more projects with respect to logistic regression, different kind of algorithms, like naive Bayes, like k-means clustering, and many more things. So again, as I said, that we will be using this Creme library. Again, if you don't know about Creme, guys, it is a Python library for online machine learning, which is also called as incremental machine learning. There are some advantages with respect to Creme. So we can say that I'll just read this text, guys. Please make sure that you watch this video till the end. It is very, very important for every one of you. With Creme, we encourage a different approach, which is continuously to learn a stream of data. This means that the model process one observation at a time and can therefore be updated on the fly. This allows to learn from massive data set that don't fit in the memory. So this is also one of the advantages. We cannot just take continuously the whole, suppose if you have millions of data at a time, right? We just cannot, suppose, and in the cloud side also, suppose in the server side or in your local machine, suppose you know that many of you know that you have 16 GB of RAM. And suppose if you have millions of records, then probably you will not be able to fit that millions of records into the main memory. So what does this say? That it allows you to train your model with one observation at a time also. That is how it can be done. In deep learning, I think you have heard of something called as batch mode, right? In batch, you will be specifying some batch size because you will not be able to fit all your data set into the memory at the same time. So over there, again, you use different kind of optimizers, you use different kind of gradient descent, like stochastic gradient descent and all. Again, I don't want to make you confused, but in short, what it says that you can retrain your model with taking one observation at a time. Okay, that is the most important thing. So online machine learning also integrates nicely in cases when new data is constantly arriving. Now you may be thinking, guys, with respect to Creme, will we have all libraries like all algorithms like how we have for sklearn? Yes, guys, most of the algorithms are actually present in Creme libraries also. Okay, so I'll try to show you to. Here are some benefits of using Creme. Uh, Incremental model can update themselves in real time. Suppose if the model is in the production also and continuously data is actually coming, you can train it at that time. It is adaptive. Models can adapt to concept drift. This is what I was actually mainly focusing on. Drift machine learning. Right? What does this basically say? This basically says that suppose I'm getting new data and my model starts performing badly. At that time, I definitely have to see that what that specific new data is. And I really want to just train my model with the new data on top of the old data that is already trained. I don't have to do the training from scratch, right? So that is also the thing that we are actually trying to focus over here. It should be production ready, working with data streams, make it simple to replicate production scenarios during model development. Obviously, so this diagram that I have drawn, okay, suppose if it is stored in the big data, I will be able to take this as a live stream, continuously take chunk of data, one observation at a time, and do the incremental training itself, right? Then it is efficient because again it requires, it need not, the model need not be trained from the scratch. That is the most important thing. Okay, it requires a little bit compute power. I'll also be showing you the timestamp that they have given, like how much time it will take to do the retrain. It has, Creme library is very good. I think you should start using it. I've been actually exploring this particular library from past 2 to 3 months, and finally I was able to make this particular video because this is one of the most wanted video like everybody was requesting. So let's start and do this by taking some very good examples, some simple examples, so that you'll be able to understand. So first of all, what I'm going to do is that, guys, we have to install Creme library. So what I'm going to do, I'm going to activate databases, right? And then I'm going to go to, I just have to write pip install Creme. Okay, you just have to write like this, and always make sure that, guys, try to always create a new environment whenever you're working with some new machine learning libraries, new techniques. That is always good. So once I install this, you'll be able to see that requirement is already satisfied. Now, once the requirement is already satisfied over here, make sure that you also do the installation, guys. It will take hardly 1 minute. Within 1 minute, the installation will happen. After that, what we are going to do is that I'm going to import some libraries like from Creme, import compose. This compose is basically used to create pipelines. Okay. And in sklearn also you have these libraries. You have libraries like feature extraction, you have libraries like naive Bayes, you have libraries like all the machine learning algorithms and many more things. Okay, only some of the machine learning algorithms like XGBoost is not present, I guess, but other than that you'll be able to find all the machine learning algorithms. So here I have imported compose, feature extraction and naive Bayes. Now let me just take a very simple example, and always remember one thing, guys. Whenever we are working with sklearn, right? Whenever you are working with sklearn, at that time you usually upload this particular data set inside data frames, and then you convert that into independent and dependent features, and then you train your model with the sklearn machine learning libraries. But in case of Creme, you have to keep all your independent and dependent features together in the form of tuples. Okay, that is the most important thing that you should remember. Okay, so in this particular case, I have taken some list of text and this, and I'll also be showing you after this. This is just a basic example. After this, I'll try to show you how you can actually perform this in a data set also, right? So that particular example, I've actually taken this, and here the first thing that we will be actually doing is with respect to NLP. Okay, and in the upcoming videos I'll be showing you other algorithms also. So with the NLP, what I'm going to do over here, I'm going to use multi-naive Bayes. And one more thing that you have to remember, guys, Creme also works with Keras. So there are a lot of videos, interesting videos that I'll be showing you, which will be very helpful for you. Now, suppose in this list, this is all my independent feature text, and this is my output. So here we are just trying to detect, like, suppose if it is having words like Chinese, Beijing, Chinese, I'm going to say yes. If it is having Tokyo, Japan, and Chinese, like this combination, it is going to say no. And one more important thing about Creme, guys, suppose in this particular example, I just have two texts, right? Two outputs like yes and no. With the help of Creme, tomorrow, if you have a new category also, you will be able to train your model. And I'll show you in this particular example also. Okay. So this is an example, guys. And again, remember the independent and the dependent feature are in the form of tuple. So this is basically the list of tuple. Okay, that is the thing. That is what the Creme libraries basically accept as an input. And always remember the first parameter will be the sentences and the second will be the labels. Okay. So suppose I have created this docs, and this is basically my docs. This is my input features in which I have to train my model. Now, as I told you, I have going to use this compose to create pipelines. Pipelines basically means I've created a lot of videos regarding pipelines, right? Suppose I want one feature like standard scalar. I want like tokenize. I want like a name bias. This is basically the name of the pipeline, and I can put any number of pipelines like this, right? I can use standard scalar also and all. Now first I'm actually going to do the tokenizer. In tokenizer, you know that we will be converting these words. In case of NLP, we'll be converting these words into bag of words, into TF, IDF and all. So how do we do that? From this particular library which is called as feature extraction. So here you can see that I'm creating compose.pipeline. Pipeline actually helps you to create, like, after one step, what is the next step that will happen. So in this case, after tokenizer, we are just going to apply multinomial naive bias. You can also add standard scalar, but standard scalar I think will not require in this particular case because this is completely a text pre-processing technique. But when I'm doing some algorithm like logistic or some ensemble techniques, not ensemble, logistic or linear regression, at that time I'll be using standard scalar. So here in my first pipeline, I'm going to basically, I have created a pipeline with tokenize, and this tokenize is doing the bag of words considering by making the lower case as false. That basically means it is not compulsory that we need to have a lower case. Okay. Now this bag of words, let us see what all options we have other than that. So if I see over here, there is options like aggregate, there is bag of words, there is target tag, there is TF-IDF, right? There is also called as vectorize. So right now I'm just going to use the bag of words because we are doing a simple classification problem with respect to text. And over here you can also check out all the parameters, what is actually present over here. So if I just copy this, and if I make a cell on top of it, so if I go and press shift tab, you'll be able to see all the parameters over here. So lowercase is very basically true or not, false, all this. Nggram by default it is 1,1. You can change it to 2,1, right? 3,1. That is up to you. So this is basically the example that I was actually taking, right? So suppose if I take this as my corpus, right? And if I try to convert this into bag of words, let me take this example also so that you will be able to understand very much easily. Okay. So I'm going to just take this. I'm going to remove this. Okay. Okay. And as I said that, I'll just go and check this example. This is just to show you guys. Again, in this project, you need not do it. So I'm just going to use this one. Okay. BOW. I'm going to paste it over here, and again I'm going to, and again all these materials will be given to you guys in the GitHub, and just check it out. I'm just making your work a little bit easier to make you understand how things work. After doing this, I can use a for loop and I can print like this. So you'll be able to see that we'll get the output something like this. This will be given as 1, like that kind of, you know, bag of words is simple, right? You'll basically be converting a text into vectors. So here you have, okay, I did not import Creme. Why? Okay, let me just import Creme also. So we will be requiring Creme, right? Perfect. So let me just execute this. Now here you'll be able to see that this is given the vector as 1 is 1, the 1, first one, document 1, this document is 2. Then here you can see all the same, like how bag of words work. This is just nothing but the counter, simple counter with respect to bag of words. If you don't know about that, check my NLP playlist, guys. And suppose if I convert this into TF-IDF, then you will be able to see that how these words are actually getting converted into vectors. But this is giving you an idea, right? This is basically given the vector this one, is given the vector this one, right? It is pretty much simple, pretty much amazing itself. Okay. Now let's go back over here. So what I'm going to do is that I'm going to create, I'm just going to remove all these things so that you don't get, I'll write it over here. This is just an example. Okay. So that you should not get confused, guys. This is just an example. Okay. Perfect. I'll remove this because I don't require this and this, right? So it'll, again, just to make your work easier. So here I'm actually creating a pipeline. In the first pipeline, we are going to do the pipeline name is tokenized. There we are actually performing bag of words. You can also perform TF-IDF. Then I'm actually applying multinomial naive bias with alpha is equal to 1. Okay. So once I execute this, this is basically my model. Now you understand one thing, guys. my docs is basically having the tuple of two things. One is your sentence and your label. Okay, so I'm just going to give a temporary name because I really want to iterate through this. So I'm putting a for loop for sentence comma label in docs. So sentence, I will be using this as my input feature, and label will basically be my output feature. Now when I'm iterating to this inside the model, inside this particular model, which is created from Creme library, you have one function which is called as fit_1. So fit_1 will be taking one sentence at a time, one label at a time, and it will be training the model. So like this, we will be training all the documents that are present inside this docs. Okay, pretty much simple. So I will try to execute this. You'll be able to see, guys, when I am actually training also, right? If I write time, you'll be able to see hardly it is taking any time, right? So the training has happened. Now what you will do is that suppose the new unseen text is like this, Tokyo, India. Okay, Tokyo, India. If I execute it, and now if I write model.predict_1 on new unseen text, okay, suppose if you have multiple text, there is again a function which is called as predict many. Okay, if you have multiple text, if you just have one text, you can use predict1, and if I execute this, you'll be able to see the answer is no. The reason why answer came as no, now again you see that, guys, yes, we did not convert as zeros and ones, we did not do the direct conversion, we gave just like that specific label. Now why this answer has come as no? Because you can see that Tokyo was basically present in the no category. India is not present over there, right? So definitely if I'm using bag of words, that value will be 0. But wherever Tokyo was 1, it is basically considering as no. Now you may be thinking, okay, Krish, fine, that is absolutely perfect. As you told that we can add a new category, just show us that particular example. Now in the future, you'll be having new text, new category, right? How do you do that? How do you train a new data into this? So for this, let's see what all things we can actually do. Now here you can see, guys, what I'm doing is that I'll just remove this. Okay, just I'll because I really want to show you this. This will be the most interesting part. Okay, now suppose I say that I don't find India and USA over there. See the words, guys. I don't find India, USA anywhere. Now suppose I really want to create a third category, because like neutral or yes or no, or it may be maybe. Okay, suppose this is my third category. This is my new text. Okay, so what I'll do is that I'll just write it over here. Training on a new data and new category. See, I'm doing both. Okay, new data and new category also. I'm doing it both. Okay, I'm just not doing with respect to only new data. New data, it is possible with the same label like yes or no. But here I'm training on a new data with a new category. Just a second, guys. I'll make it as code, and this I'm going to make it as markdown. Guys, this is important. Just see this. So here I have written fit_1 India, USA, and I have written maybe. Okay, and now I'll execute this. Okay, I've executed this. Now suppose my unseen data is something like this. I'm going to just write it down over here as India, Germany. I don't have Germany over there. And if I try to execute this, you are able to see that now it is being able to predict maybe. Initially, understand, my model that was initially trained was not trained on this maybe output class. But just by using this fit1 method, I will be able to train this. Now suppose if you have many sentences also, you can loop inside that, and you can use fit1. And again, guys, with respect to each and every sentence, you will be able to do it, right? Now what is the main thing that is actually happening over here? You're training on a new data and you're training on a new category. Like that, any number of categories may be taken. And yes, sometimes to get reflected, sometimes you require some good amount of data. But again, what is the thing that is happening over here? Here, the incremental training is happening, because after my model is getting trained, any new data that comes in the live stream, I can train with that. And tomorrow, suddenly I have a plan that I may have a new category in my data set. I may directly train it by the use of fit1 method. So here you can see, by using fit1 and by using the predict1, you are able to get the new category. And again, here I've just used India and Germany as my next keyword, right? I hope you are able to understand this, guys. So this was one example of NLP. with respect to this. Again, I will also show you the logistic regression which I have actually created over here. Okay, this is just my logistic regression, Creme with logistic regression. But I really want to show you and complete bigger problem statement. This was a very small data set, right? This was a very, very small data set. Now let me just go with incrementing model retraining approach with a huge data set like spam and ham. Okay, like spam and ham. So here you have import pandas as PD. I'm reading some data set over here. This data set will be given to you guys again in the GitHub. So I've just used some separator /t, and here you have names, labels, and messages. So I think I have downloaded this data set from UCI website. So once I execute this, you'll be able to see that in message.shape, I have 5572, right? So I'm here using a sklearn model selection to do the train test split, because obviously we require to do the train test split. Now inside this train test splits, I'm not doing xtrain, xtest, ytrain, and ytest, but instead I'm doing train and test, because I want to combine those training input sentence and the label in the form of tuples, right? That is the first requirement with respect to Creme. So here we have message underscore train. Did I not execute this? Messages underscore train. So it should be message underscore train. Okay. So this is basically my message underscore train. Okay. And now what I'm doing is now this message underscore train, I am actually now converting this into 2 records. When I convert this into 2 records with index is equal to false, this will convert into a list of tuples. So here you can see we'll be able to convert the data frame to a list of tuples. So I am trying to convert this for my training data set, also for my test data set. So if I execute this, and if I now see my message train, here you will be able to see the list of tuples. So here you have, first you have ham, that is your output feature, then you have a sentence, then you have ham, then you have your output sentence. So something like this. Similarly, I have done it for the messages underscore test. Perfect. That is the first requirement. As I said that over here, we need to convert this into tuples. That was the first requirement that I told you over here also, right? So we have converted this into tuples. So this whole data is basically in the form of tuples. Now, now obviously we'll be creating the pipeline. The first pipeline is basically to create the bag of words. So here in this case, I've taken TF-IDF. So you want to see different approach also. So I have written TF-IDF. Then the second function is basically multinomial naive Bayes with alpha is equal to 1. I hope this is pretty much simple. Okay, compose is missing. Where is compose library? Okay, so let me just import the compose library from here. Okay, I hope so it works. I know there'll be some more error because I have to use this feature extraction everything. So I'm just going to import everything over here. Okay, just to because this is another cell, right? So this is done, right? Our pipeline is actually created. Now see, when I'm training with my training data set also, right, or any new data, we will also be able to track the accuracy. We will also be able to track the accuracy. Always remember that. Now in order to basically track the accuracy, what we have to do? You know that we have imported a library which is called as metrics. I guess somewhere we may have Creme metrics. Okay, so what you can do is that you can upload one more library. You can say right from Creme import metrics. Okay, so this metrics will be having metrics like MSC, mean squared error. For classification problem, it will be having like accuracy and many more things. Okay, you can actually see over here, you can write metrics dot tab. Here you have a lot of things like classification report, confusion matrix, cross entropy, F1 also you have. So any kind of metrics you can basically use. Again, it has a lot of metrics, guys. So this Creme library is becoming very much popular. So here what I've done is that I've taken metrics. I've used the accuracy inside this metric parameter. Now this metric, you know, when we will be updating, this will basically be getting updated with the newest accuracy. Now one thing that you need to know is that as my model is training one by one record, and that accuracy will also get accumulated. So if I write something like this, see what is happening over here, right, guys? And please make sure you see the video, guys. For label or sentence in message underscore train, now I'm training with all the message underscore train, all these particular values. You can see that first is basically label, right? I will be considering this as my label and this as my sentence. So that is why I've used label comma sentence. Then I'm writing model.fit1 with sentence comma label. Okay, sentence comma label. I hope it is pretty much simple. Then I'm also doing the prediction or predict underscore 1 on sentence, and I'm actually capturing the ypred value to just see that how the accuracy is being followed for the training data set. Now this ypred, what we do is that we will be using this metric.update. We are going to basically compare label and ypred, and what will be the difference that will be updated in the metric. So in short, this metric will be giving us the value of the accuracy, and this will happen for every record. It will be keep on updating the accuracy parameter. It will keep on updating the accuracy parameter. I'll not print this metric for every iteration, guys. I'll just print it for the final iteration. So this is how you can see that how quickly this whole fit one has been done, because there are more than 5,000 record. Now if I go and see my metric, you'll be able to see that the accuracy that we are getting is somewhere around 95.84% for the training data. Okay, for the training data. This is what we actually see over here. Okay, you can also convert this into X and Y training data sets and all, but I'll not do it right now to just make your simple things simple. So what I'll do is that I'll delete this. Okay, now this is basically with respect to my training data accuracy. So I'll just write it down over here, training data accuracy. But you can see, right, how fast it is, how good it is, right? Then after this, what we are going to do is that we are going to test it for test data accuracy. Test data accuracy. Now for the test data accuracy, again, we are going to use metrics.accuracy. Okay, and this I've written it as test metrics. Now this time I'll iterate through message underscore test. Now I'll not do fit. I'll just do predict underscore 1 for the sentence. I'll get my ypred and I'll just update my metric parameter with label comma ypred. Now when we will be executing this, guys, you will be able to see that we are getting an accuracy of 95.81, 95.84 for the training data, right? For the training accuracy and for the test accuracy, you will be able to see that there it is very, very less difference are there. So that basically means our model has trained properly, right? It has been amazing. It has been very good itself. And here you'll be able to see a lot of things itself, right? Now, what we can also do is that we can, apart from this, you will be able to see that we can also train on new data set, right? Suppose this is your new data set. Suppose you want your new category, you can put it over here. Suppose I'll say the guy is neutral. I can say it as, okay, it is not a spam, it is a ham. Everybody is neutral, it is a ham, right? You can fit any number of data like that, any number of times. And this is where live stream data will come into picture, because live stream data, suppose you are getting one data every time, you iterate through that and you keep on executing with fit underscore 1. And again, I've shown you from this particular example, you can also add any new number of categories, like maybe you can add categories like neutral, spam, ham, neutral, anything. And here you can see that every time you'll also be able to monitor as you are doing fit underscore 1 with respect to each and every records. Now this is how incremental learning model retraining approach works, guys. If I take an example of one more like logistic regression, so here you can see that I've taken a data set which is called as phishing data set. This is actually present inside the Creme library itself. Again, we have created a pipeline, and here now you can see that we have used pre-processing. Inside this pre-processing, we have used first of all standard scalar technique. That is basically we have done standard scaling, and then we have applied logistic regression. Again, this logistic regression is present inside linear underscore model. In sklearn also there is something called as linear underscore model, right? I hope you all know that. Then again, here also I'm again taking metrics underscore accuracy, and here you can see that I'm finding out, making a prediction, updating the metric, and makes the model learn. So any machine learning algorithms, and again guys, there are many machine learning algorithms, you just have to follow this GitHub, you have to follow their documentation. I've taken this particular example from here itself, and I have updated over there. So here I've shown you one end-to-end example also, I've shown you NLP example also, I've shown you logistic regression example also. One final thing about the performance metrics, why Creme is very, very good. So here you can see some of the methods that were used, like linear regression. Keras on CPU was actually used. Okay, Keras on TensorFlow, which was used on CPU. For the average fit time for the incremental learning, right? For Creme library, it took 18 microseconds. Every time it was, retraining the model with the new observation. In Keras, it took 1 milliseconds. In PyTorch, it took 577 microseconds. In Scikit-learn, it took 305 microseconds. Whereas the predict time also, you can see that Creme is having the less time, that is 4 microseconds. Now you can understand the importance of Creme. So what I'm going to do is that, guys, I'm going to create this whole model retraining approach with the help of Creme. There will be many projects that I'll be putting inside this, so that anywhere you say, now you can put in your resume that how do you do a model retraining approach, because this all can be done offline also. But in case of live stream data, I'd suggest that this can be done in the cloud itself, because the amount of memory it will take is very, very less, right? So yes, please go through this. I hope you like this particular video. Don't forget to subscribe, guys. I would like you all to share with everyone, share in the LinkedIn with everyone this particular thing, guys, because many people don't know this. I really want you all to know all these particular techniques so that you'll be able to get jobs. So I hope you like this particular video. Don't forget to subscribe the channel, guys. Press the bell notification icon, and many more videos are actually going to come on model retraining approach. And all this particular thing will be actually shared to you in the GitHub, and you can actually follow it from there. So I hope I'll see you all in the next video. Don't forget to subscribe to the channel. Thank you, Underdog. Bye-bye.